Welcome to our virtual presentation of the Sony Healthcare exhibit, originally planned for the 2020 ASH PDC Summit. We hope everyone is staying safe and healthy. Although we couldn't meet in person, we'd like to take this opportunity to present an in-depth overview of our new OR integration solution that we would have exhibited at the show. It's called Nucleus. Welcome. My name is Dave Alexander, and I'm the marketing manager overseeing our integration platform, Sony Healthcare. To those I've met in the past, it's nice to connect with you again. To those that I have not, the pleasure of course is ours, and we want to thank you all for taking the time to attend today's event. Today we're fortunate to have on the call a few of the key parts and players of the core development and engineering teams in Nucleus, including Mark Barron, Senior Engineering Manager, Healthcare Solutions and Nucleus, Marco Menares, Senior Solutions Engineer with Nucleus, Shogo Obuchi, Product Development Engineer and RAQA Liaison, also with Nucleus. All on the call. In the US, Nucleus was 510(k) approved just in March of 2020. Although the product has been widely sold around the globe for quite some time. In just less than 2 years, we have over 500 ORs with Nucleus installed. And here in the US, several projects are already in progress at some very prominent facilities. Today, you will see a system that represents the modern means by which to provide and manage enterprise-based integration. It's a modular, software-based platform. It has an unparalleled ability, therefore, to manage the functionality and reduce deployment costs compared to traditional wired AV systems. Essentially, you can add or subtract software as you wish, with no large cable plant project required or costly technical service calls needed on site if you ever want to manage or modify part of a system. As architects, planners, designers, and consultants, this methodology represents the most logical, advanced, and cost-effective product to be specified for your projects. Again, costs, because of this factor, are easily controlled. Since it's a network-based product, many efficiencies result. Nucleus is remote monitored. Nucleus is maintained remotely. The system is geared to utilize existing data infrastructure so that, again, no new large-scale AV cabling project is required, thus saving valuable deployment time and, again, reducing costs. Before getting deeper into some of the technical aspects of Nucleus, we realize that some of you may not be familiar with Sony's healthcare product portfolio. This quick overview will illustrate our healthcare heritage and our experience in the market that has led to the development and launch of the Nucleus platform. Recorders right here in the center. Sony recorders have been used by radiologists and surgeons for decades, literally, to capture procedures for training, education, and appending to the patient record. Sony's first medical product was a pneumatic 3/4-inch tape-based recorder. Let me say that again, tape-based recorder that was launched in the mid-80s. As technology progressed and the need for surgeons and staff to record directly to a central server, system, or archive, Sony introduced its first network recorder in 2008. In cameras, as the worldwide leader in image sensors and camera technology, our sensors and component-level camera modules are used in the majority of endoscopic, microscopic, and robotic surgical systems throughout the world. We also offer a large portfolio of finished cameras, such as ceiling and wall-mounted PTZ units, of course used in ORs and many other locations, for room monitoring, patient monitoring, and obviously security. When it comes to printers for the OR, Sony here too also has #1 global market share of units sold for hard copy imaging, a position we hold in diagnostic imaging as well, with modalities like ultrasound, C-arms, and X-ray across modality manufacturers. but you probably know us for our surgical displays. Sony is the #1 global manufacturer of surgical displays. We have a full range of 2D, 3D, HD, 4K, 3D, 4K, all of the above monitors in all shapes and popular sizes. Since 4K endoscopes are rapidly becoming the industry standard, surgeons the world over have come to rely on Sony's 4K displays for the finest detail and truest colors, crucial elements of their work. In fact, our pioneering continues in the monitor world as we are about to launch our latest, a 32-inch 4K display, the LMD X3200MD. We actually have a small preview for you. Again, it's 4K, it's 32-inch, new size. For Sony, it's 16:9 at a sweet spot size with a single cable connection capability for all signal types. HDR makes the image on this monitor pop. Has to be seen to be believed. It's got an installation-friendly back end and port for cabling. So once it's installed, it's very clean and easy to manage. Through the years, Sony has continued this vision and focus in its R&D efforts and expanding the IP-based technology that we utilize. It can truly transform the integrated operating room. Once the digital approach to the data-rich environment that is all of healthcare is accepted, Nucleus emerges as a viable means by which to create and manage exponentially increasing volumes of data across your enterprise, of course. But as we know, IP as a means of video management is taking over. Nucleus, as an IP-based system, offers an all-in-one approach to switching, content management, or recording, broadcasting as well, and all are geared for enterprise deployment from the data center. After all, IP video is taking over in such a large way, based on the information from one of the largest networking companies in the world. 1 million minutes of video content is streamed via IP per second. 1 million minutes per second. The study went on to say that it would take an individual more than 5 million years to watch the amount of video that will cross global IP networks each month by the year 2021. That is what I call binge watching. The principle is simple. Video sources are transported via the network to a central server. Imagery is then transported to its destination, either a local monitor, a video archive, the classroom, to a pathologist, wherever it's desired. Nucleus is secure. ORs are 24/7 managed, not just monitored. The depth of functions of Nucleus, as you would imagine, are vast, and the potential configurations that it can be offered in serve many applications. On that note, for more on the specifics of the overall system and the technology, we're going to turn it over to Senior Engineer Mark Barron. We will come back for Q&A, but right now we're going to flip over to Senior Engineer Mark.
For those of you who don't know me, I'm Mark Barron. I head up the Solutions Engineering Group here at Sony. I'm going to go into some really top-level details on video over IP and then drill down into the specific Nucleus product. So I'm hoping everybody can see my screen. So why video over IP? So first of all, let's start with a little glossary. So IP, for those who don't know, is the Internet Protocol, and it's the method of sending information, specifically data packets, over Ethernet networks. And what does this really mean for AV over IP? It's very flexible. It's less time to cost and adapt. It's designed to be bidirectional, and it's not predefined, such as a video matrix switch, right? Video matrix switches, which have long been used in integrated operating rooms, are predefined as 8x8, 16x16s, or so on. Whereas we're moving away from that model into video ubiquity, which means that instead of searching for a specific port to plug a specific modality into, really all the nurse or technician has to do is search for an RJ45 or network jack. So one of the primary reasons for doing video over IP, and one of the really most important factors is low latency, right? The doctors, especially in endoscopic surgery, they're staring at their hands and they're looking at the monitor, and they want to make sure that they align. We can't have very long latency between the period of taking the information from the camera head and displaying it on a monitor. So low latency is very important. The other one is really we have to accommodate many resolutions. In our case, we support everything from legacy analog systems, which are still out there, in a number of different formats and a number of different connectors. And I'm going to touch on this as we go forward. So this is just a brief view of what goes on in an OR as far as modalities that connect into an OR, but also their specific resolutions. So you see that on the left-hand side over here, we still have to support old legacy analog systems, but all the way through HD to 3D and 2D up to the current generation of 4K. So what other advantages does video over IP give us? And that is just the basic Ethernet infrastructure that exists in all hospitals. So in most cases, they're already running copper, and they could be as low as Cat5e all the way up to Cat6a. The nice thing about our system is that we have compression schemes that can accommodate existing 5e. So that means that from a hospital perspective, they don't have to go in and rewire to accommodate an integrated OR. Obviously, if you want to get into future proofing things, you want to get at least to Cat6a to accommodate 4K signals, but even at fiber. And our system can accommodate either one of those things. It comes out of the box as copper available, and it can be very easily made to work with fiber multi-mode LC duplex. We use off-the-shelf switches. So now instead of having a dedicated video matrix switch, we're just using some of the infrastructure that's already existing in the hospital with either 1 gig or 10 gig switches from a variety of manufacturers. The huge benefit is that IP and video over IP has been around for a little bit of time, and they have been proven to be very robust. They move millions of megabytes of data a minute, so they have been proven to be very reliable. Scalability, it's quite easy to add another room or another modality to a system by adding another port on a switch. So you don't have to buy any other equipment. You just basically add another port availability on the switch. So from that perspective, it's really unlimited expandability, and these switches are ubiquitous and open standard. So for instance, you can start with a 1 gig switch. You're great for HD. If you wanted to move up into higher resolutions, you would then have the ability to expand into a 10 gig switch. So this is kind of a basic layout of what a network topology looks like, and this provides us huge flexibility. One of the most important things as we get into a hospital and talk to the IT people is the quality of the network is very important. Video traffic is very vulnerable to packet loss and delays, so we have to make sure that the quality of the signal path is very robust in the hospital. And we work closely with IT in talking about our requirements and dedicating VLANs for those purposes. Let's get into a little bit more detail with our specific product, which is Nucleus. And the original impetus for this was, what are the challenges that the hospitals are facing, right? So ORs are changing fast, not only from the standpoint of different procedures, but also the different technologies. different resolutions, different formats, and a driving factor from the hospital side of things, from the administrative side, is improve efficiency, maximize ROI, but also maintain good patient outcomes. So that really drives a very flexible need, and something that we feel that video over IP can fill. So this is where we are today in many hospitals. Typically, you have a video matrix switch somewhere on the network, either in the room or right outside the room in the sterile core. And the nurses are always searching for a specific wall jack to plug something in. And we call it the alphabet soup, right? So you have many different physical connectors here. The other downside of this is that Biomed has to stock a number of different connectors, right? We all know that these cables are running over the floor, they get run over, they get broken, and they have to be replaced. So Biomed has to have a ready stock of this type of cabling. And also, because of the fixed locations of these jacks, you're always putting the modality where the jack is, not necessarily where it needs to be, and this causes a lot of cables to be run across the floor. When we move into an IP world, you move the product to where it needs to be, and since the RJ45 jacks are ubiquitous, you can always find a place within 6 feet of that jack. So the new approach, so the funnel off to the right-hand side there kind of shows that all the different signals and the different connections are all funneled down into a single RJ45 jack in the idea of copper. In the idea of fiber, it would be an LC duplex cable. But for today, let's just concentrate on the copper scheme, which is that all of these products or all these signals go into either an IP converter, whether it's a transmitter or a receiver, and out the other side comes an RJ45 jack. So this is standardized. The cabling is very inexpensive. Biomed stocks different lengths of RJ45, so if they do get run over, it's very inexpensive and very easy to replace that single connector or cable, instead of having to search for a specific cable and have sizes of cables that are too long for what you need it for. So in this way, we say that our outputs and inputs are limited. Again, we've talked about before where you size an OR today as either a 16 by 16 or an 8 by 8. We're not limited to that. We can have as many inputs and as many outputs as you have wall jacks in the room. We talked about the cable clutter, how we're doing away with that by moving the product or moving the modality to where it needs to be and not where the jack in the wall actually is. And the Nucleus has a very interactive, intuitive user interface. And we'll show a little bit more about that as we move on. So a couple of taglines here. See anything, access at any time from anywhere. That's kind of our mantra. And that really comes with the ubiquity of having a video over IP platform, right? So we're modality neutral. We can take pretty much any standard video signal from any modality, and we can route it and switch it to any display. Everybody is standards based today, so we can move things from point A to point B very easily. Some of the options we have is you can also stream this, so you can actually broadcast this from OR to OR, OR to classroom, OR to doctor's office, in addition to recording and archiving. And remember, we talked about routing and switching is kind of unlimited from your IO standpoint. Every one of the inputs, every modality with a transmitter is able to be recorded. So we're no longer limited to having a box that's dedicated to recording 1 or 2 signals. Now every modality in itself can be recorded. So we can have multiple modalities being recorded, routed, switched, and viewed at the same time. We also add telestration and distance learning. Distance learning kind of goes hand in hand with the streaming concept. We talked about some of the scalability and expandability. And lastly, we're going to touch on the Nucleus Smart applications, which is a very unique aspect of our system. So from the simplest standpoint, the IP converters, we'll refer to those as IPCs from here on. You see that on the one side here in the endoscopic tower, you have an IPC transmitter. It takes the information from the video signal from the endoscope, whether it's SDI or HDMI, it converts it and puts it out over the network. And then on the receiving side, you have a receiver, an IPC receiver.
Hey, Mark, I think we lost your audio.
Can you hear me?
You seem to be back now, but we missed the last about 5 seconds of what you were saying. Oh, hang on.
Restored. So we talked about on the one side we have our transmitters, receivers. So this is two different units. One is actually specified as a transmitter. The other one is specified as a receiver. We can take information from the endoscopic tower as a video signal and output it to the receiver, which is then transcoded onto the monitor in multiple different flavors: HDMI, 2D, 3D, 4K, HD. And this is just in a simple point-to-point application. If we actually look at an OR, we have multiple modalities and multiple displays. Everything is connected to the network, so you can pick from any one of the modalities and display it on any one of the displays. Again, using the infrastructure of the hospital on the backbone of the network. This is a little graphic of what this would look like. So again, we talked about any modality, whether it's an endoscopic camera, surgical robot, ultrasound, take it to any display, not only ours, but competitive displays. Again, we're all standards based in multiple layouts. So depending on how or what they want to see on any one of the displays, we can display a side-by-side, picture-in-picture, quad view, etc. So the networked operating room, if you look at this part here to the left of the teal line, this is inside the operating room, this is outside the operating room. So from a footprint perspective, within the operating room itself, every one of the modalities would have a box. These are the transmitters that's then fed into the IP network, and every one of the displays would have a corresponding receiver. So that is the effect of the footprint requirements within the hospital. The displays come with a bracket so that we can sandwich the transmitter between the bracket, between the display and the boom arm. So really, from the user perspective, it's not even seen. It's kind of behind the scenes. Then we can talk about outside the OR. In this respect, we can take information from the OR and broadcast it outside. So use cases would be to the auditorium, to the doctor's office, to a classroom, to the student lounge. Obviously, you know, there's a big push to keep infection risk outside of the ORs. And there's also the teaching side of things where they want to get students into the ORs. Well, if you can now be in the relaxation of a student lounge and see the same thing that's going on in the room, you have a lot more flexibility. So the strength of the system and all the software resides in the back end, in the data center. The data center could be anywhere on the campus, it could be anywhere within the hospital, and all the information transmitted from the receivers and the transmitters reside in the data center. So it's a climate controlled location that's, you know, far away from the operating rooms. You're not taking up valuable real estate in the OR itself. Of course, the primary concern is patient safety. So the question is, what happens if the network fails? So every one of our systems, we do a primary cabling in video, typically HDSDI, because we can run that 100 meters. So from the transmitter, we have a direct cable connected directly to the display. So if anything happens, the system will detect it and through RS-232 can switch inputs. So your primary input may be HDMI on channel 1. If something happens to the system, we can fail over and go directly to the other channel remotely and automatically. through RS-232. So you would see a momentary glitch in the system, but you wouldn't be blind for your operation. Seamless and neutral integration. So we can take from the one side of things, which is the hospital information system, whether this is EHR, hospital information systems, PACS, we can move information back and forth into Nucleus from this. And then from the clinical side, we can take the information of the video from the modalities themselves and bring them into Nucleus, marry the two, and put them together into the patient record. Whether it's capturing still images in the operating room and sending them to PACS, or whether it's bringing a modality work list in through the hospital information system so that nurses can very quickly set up a patient. The flexibility of Nucleus in this respect is really beneficial. So one of the primary reasons for integration in the OR is routing and switching. You want to be able to move information or displays, video information from point A to point B, and you want to have the flexibility to do that on the fly. So if you look at our interface here, across the top are your sources, and down the left side are the displays. So for instance, you have ultrasound, you have some surgeries here, and then in between these two, as a matrix, you would then pick and choose what you want on any display. So for instance, in this case here, I have this surgery is going to this display here. This display is set up as side by side. So you see those two white here that, so left side, right side, you would pick and choose what you want to have on the display. So in this case, you have this image on the left side, this image on the right side. We have a number of different layouts and you can choose those on the fly. This is a picture in the picture. This is a single display. This is just a different type of picture in picture. So again, very easy for healthcare personnel, clinicians to choose and pick what you want to put on any one of the displays. Additionally, you can have things preset up by doctor, by procedure, by OR, so that you don't have to worry about this. If you have repetitive procedures and you know that they're always going to be set up the same way, you set it up once, and it's very easy to recall those. Recording and archiving, again, we touched upon it, but once you have an IPC connected to a modality, it becomes a routable and also a recordable source. And we said that we can record any number of those videos simultaneously from any number of sources. We talked about the ubiquity of signals and formats. We can record any one of those, whether it's HD, 4K, again, all simultaneously. We can have, from the post-process point of view, anyone from a computer on the hospital network with the proper credentials can go back in and edit those videos. They can share them, download them, or send them to specialists. Nucleus uses the infrastructure of the hospital itself. It's not a storage medium by itself. We connect with the hospital infrastructure, whether it's a SAN, a NAS, or any other type of storage solution, and we utilize their storage instead of our local storage. We take things as a cache, hold on to them until we can pass them off to the hospital. The hospital then can do disaster archiving for the long term. Collaboration, a number of different ways of talking. We actually call it broadcasting, or more locally known as streaming. The idea is any one of the videos that is present in the operating room, we can stream to a remote location. So for instance, in this case, the doctor, he would have his PC connected to the network. He can log into that particular operation and he can view the operation in very low latency, almost near real time. Again, the same type of idea with an auditorium. If you're doing grand rounds or if you're doing a seminar, you can broadcast directly from the OR to the auditorium and have bidirectional audio. So it's very easy to set up on an ad hoc basis. You don't have to have a specific time. You plug into the wall, you acquire the operating room, you log in, and you can instantly see the videos. Smart applications is where we move from into the dynamic world of aiding and assisting the clinicians to make better clinical decisions or aid and assist in the operation itself. It's no longer a passive routing and switching system, but because we have digitized the signals, we can add software algorithms and benefit in the clinical decision making. So it's all done in real time from SD all the way up to 4K. And it's all enabled through the centralized computing power that we had talked about in the data center. So for instance, if you wanted to have some of these smart applications, we could then generate more powerful PCs and allot that CPU processing time to these specific applications. So again, it's available anywhere in the Nucleus network. It's very easy to upgrade. If you don't want to have those the functionality in the beginning, then we can add that very easily remotely by adding the license through software. So one of the examples of a smart application is our rotation correction. Sometimes when using oblique endoscopes, you are twisting the endoscope to kind of look around corners and things like that. Unfortunately, what comes with that is that the entire camera view rotates along with it. So enabling with our unique intellectual property and our algorithms, we can negate that by keeping a constant horizon. So as you're twisting the endoscope, the view to the user remains the same. It doesn't twist along with it. So you're always maintaining that horizon instead of twisting your head to try and see what's up and what's down. We can do this in real time up to 4K. This is just one of the smart applications that we've enabled at this point. A large benefit of having things on the network is that we can do remote network monitoring. David's going to touch on this in a little bit, but we have our monitoring system, which is called System Watch. What it does is it monitors hundreds of data points 24/7. It will detect an anomaly or an add a parameter, and it will send an email to our network operations center where someone can then tunnel into the system, get online, and diagnose and troubleshoot over the network rather than have to send somebody physically out. We are looking at somewhere about a 95% success rate of making sure that things are working and getting things back online without having to send somebody out to the site. So in conclusion, let's talk about scalability. Again, using the IP technology makes it ubiquitous. It exists in every hospital. It's very easy to add a new modality as they're necessary. All you need is one of our IPCs. Very easy to add rooms, very easy to add modalities, and easy to add functionality. Again, the software can always be licensed remotely without having to send somebody on site to add future functionality. We can handle anywhere from a single patient room to hybrid interventional radiology rooms to over 100 operating rooms using the same backbone of the hospital. And this works not only throughout the hospital or throughout the campus, but also beyond. Modality neutral, again, Sony does not make endoscopes and we have to work with everybody. So we can take any signal from any manufacturer at this point that is known and get it into the Nucleus infrastructure and have it a video routable switching or recording or broadcasting stream. As far as control is concerned, we can add future controls such as procedural lighting, in-light surgical cameras, and competitors' displays. We can control brightness and contrast and things like that. As long as we have that protocol, we can add it to the system. So now you have a single user interface, not only controlling Nucleus, but also some of the other aspects of the room. Future-proof, right now, as I touched upon, we can handle every signal, whether it's any connector and everything from analog all the way up through 4K. Additionally, Sony has a very strong R&D center. We're ranked 14th in the world right now. And we take from that R&D, whether it's from broadcast, whether it's from consumer, and we look for that all the time to see how we can make improvements into the Nucleus product by adding that functionality into the surgical workspace. I touched upon the open API we offer the API to anyone who wants to build on top of our application. So you might have your own smart application idea that you want. If you develop it, it becomes your property. Additionally, we're always talking to customers, and we're working on that on our side to add that features and functionalities to the general system. That's all I had. I'm going to send it back to David.
Great, thanks, Mark. What we wanted to touch on just before Q&A, the System Watch. We want to make sure that we understand that System Watch is a complete service for maintenance and monitoring. This is not a simple ping of the system like some of the conference room control systems are capable of doing. This is checking constantly for network traffic, functionality of every box. When someone has a C-arm and they accidentally unplug the IPC, a notification is created. It's very effective form. We did have some other points wanted to make sure you had in mind. Today, we do have over 500 ORs running Nucleus, several installations in progress already here in the US, and you can bet we'll tell you all about those as soon as we're authorized to do so. Nucleus can be used to build patient monitoring systems. Today's situation, the use of pan-tilt zoom cameras in key areas that are being converted to patient areas, certainly a prevalent thing going on around the world with Nucleus customers. The system is geared for existing infrastructure, and yes, of course, it plays nice with fiber. Every video transport mechanism would love that. No equipment racks in the ORs. This is a huge point. There's no dust collecting in the corner. Less to clean, faster turnover, and maybe you would clean, that rack off otherwise every few days. Save all that time. Makes for a very pediatrics and neuro-friendly, orthopedics-friendly system. Again, the remote maintenance and monitoring not only helps us maintain the system, but it keeps technicians out of the OR. Another great factor for pediatrics and other more sensitive rooms. And once the base backend is in place, adding additional rooms is notably cost effective. As you would imagine, once the system servers are in place, all you need are the local components within the room, the IPCs, data cabling if you don't have it, and your monitors, and you can add another node onto the Nucleus backend. There are no limitations in the number of inputs and outputs of Nucleus. Wrap your head around that for a minute when you think about the switching situations that you've had to wade through and in the past to decide what sources should be switched and what should not. It's an unlimited number of inputs, unlimited number of outputs, and again, anything that is fed to the system as an input can be recorded. The smart applications, more and more coming out all the time. Things like patient distraction, very helpful in peds and certain things where the monitors suddenly and uniformly play a cartoon or some other animation with some comforting background music. Patient distraction, a great feature, and just another example of a quote unquote smart application that we've developed. For many other smaller applications compared to a typical OR, things such as urology, ENT, OB, ophthalmic, wherever there are few sources within a room, can all still be benefited by Nucleus. For the recording functionality, they can become a node in a Nucleus system, now have all the functionality of the ORs, but literally with just, for example, 2 sources. Now you can record and archive, pull it all back up. You can stream, you can broadcast, all the things you can do with a large system. Again, we talked about System Watch, and again, as long as you understand the magnitude of that and how it provides just a higher degree of uptime, then we know you're getting the point. Wanted to thank you all for listening. Thanks for your patience with the graphics, but it is time for Q&A. So we wanted to hand that over to the floor, and now have a few minutes for Q&A for anyone who has questions.
So yeah, anybody, please submit your questions. I can see them and I'll read them out loud. So the first one is, will this session be available to send out to our staff? They downloaded the brochure, but the recordings will be available. I don't know how they're going to be sent out, but I think they are. This is being recorded and it will be available to be sent out.
Yes.
Anybody else have any questions? I have with me, I have Marco Manjares, who is our network system guy, and then we also have Shogo Obuchi, who is the product manager for and subject matter expert on Nucleus. We have a question: what kind of latency can we expect from a transmitter to receiver? It's in the millisecond range. We don't specify give a specification on that, but it is less than 2 frames. Another question just came in. I imagine this is scalable depending upon the number of connections needed, but what's the average capital outlay for an average system sale? We can take, if you have this kind of a need, we can put you in touch with one of our salespeople, and everything is pretty much customizable, so we don't give out a quote as far as that's concerned, but we can follow up with you and find out your exact needs and come together with a system exactly for you. Is there a license to purchase to record for each device you connect? The way the licensing scheme works is you buy the recordability based on the recorder. I'm sorry, based on the transmitter. So there is a license fee for how many you are going to be recording in a room. So for instance, you could have between 1 to 5 in a room, or even larger than that, and the license fee is based on what you need. So we're not charging you for functionality or a situation where maybe too large, right? So the granularity of our licenses allow us to scale down to your specific application. Okay, a couple just came in. What OS does the backbone run on? So we run on a Linux system. Marco, can you add some more to that?
Yes, we're running in the latest Ubuntu 18.04, I'm sorry. So it's long-term support from that perspective.
Another question, do you need a transmitter for each device you connect? Yes, that's the idea, is that every modality would have a transmitter so that it can be placed on the Nucleus backbone. And then from there, we turn licenses on and off based on your need for broadcasting, streaming, recording, and archiving. How long a process is a typical installation take? That's one of the really nice things about our system, in that since our infrastructure is mostly behind the scenes in either software or in the server center, the data center, the servers are usually racked and stacked by the local hospital. We test and configure everything before we ship it out, so it should be pretty much ready to go. Our on-site time is devoted to connecting the IP converters to the displays and to the modalities themselves. But from that perspective, it's much faster to get up and running, and the installation time is much less than it would be for your basic video baseband. Are you seeing hospitals move to 10G for installments like this? It depends. If you are an existing hospital running 5E or Cat6, then you're fine to go with 1G. If you're future-proofing, or if you're doing a new build or a complete renovation, it would be wise to put in a 10G, because you can do 4K very easily. But if you're looking to the next 5 to 10 years, you probably also want to be looking at 8K as that comes down the road in medicine. Marco, did you have anything else to add on the 10G?
Yeah, typically speaking, I mean, you see 1 gig going to the edge devices, so inside of the operating rooms. And I think a lot of the hospitals are already most likely ready on the back end. So from the operating room central point, from your IDF going back to your data center, the hospital is probably ready with a 10 gig backbone. So the system will be able to work on those conditions as well.
And just to dive down a little bit deeper, so when we connect typically from the operating room, we go to an IDF closet or an IT closet that's somewhere on the floor. So that's typically where our network switch will be. So we make home runs from each of the OR wall jacks back to the IDF closet, and then the IDF closet connects with high bandwidth from there to the data center. So another question, could you tell us one account in the US that we could cite as a reference center? David, I'll throw that to you.
Yeah, we're working with several, and you can imagine it's literally been installed within the last 30 days. So they're in, final legal review to allow us to publicize. So I can't divulge all the information just yet. But rest assured, it'll be all over our PR efforts and our websites and LinkedIn. But it's several, West Coast, East Coast, coming about, and we'll make sure you hear all of it just as soon as we're able to tell you.
Yeah, we're a little bit more mature in that respect with international installations. So we have a number of those that we could also reference. And since they've been installed for a longer period of time, the clinicians are much more aware and at ease with the systems, and we can put you in touch with them for different specializations to discuss their impressions with the system. How is training for employees handled? So from the everything is pretty easy from the usability standpoint, right? So everything is on a touch panel that's located in the operating room. We handle go live support. It's typically 1 or 2 days, depending on how many rooms you have or how many shifts. We will handle training for every one of the shifts to make sure they're comfortable. We'll have at least one person on site through the surgical day, going between the rooms, making sure everybody's comfortable with the system. But typically it's 1 day, you can have it up and running. Can you describe a scenario where optical fiber can be integrated with Nucleus? I guess the easiest way of saying is in the room itself, when you move modalities in and out, you can have fiber from that point all the way through to the back end. However, fiber is very flexible, very fragile. So what we have been doing is you can either have armor fiber cables, which is expensive, but it's also kind of bulletproof, or you can go copper from the modality to the wall jack, and then from the wall jack and everything back through there, where it's not going to be subjected to the abuse is going to be fiber. So that's one of the installations. So you can do a couple of different ways. The hybrid approach where you have copper from the modality to the wall, and then optical everywhere else, or you can go optical from beginning to end. So either one of those would work. In terms of route to market, what's been the main focus in the US market? Sony is going directly, selling straight to the end users or through solution partners, and yet are you guys been able to deploy the solution remotely? I can handle the remote part of it. You still need to have, even though we have virtualization on some of the servers, we still have to send people on site, so we cannot do a 100% remote installation. We still have to have somebody go in, configure the system, make sure the servers are mounted correctly, make sure that the connectivity is there. But as far as the route to market, David, do you want to touch on that? The main focus of Sony is going directly, selling straight to the end users or through solution partners?
Sure. Currently, it's through our solutions partners, our system integrators that are our dealers for our healthcare products are the primary means in terms of the distribution channel. We're kind of in the first month here, so things are still developing there as to what dealers are interested in this types of product, who's geared to handle it compared to who's not. But essentially, it is through our existing partner base that, of course, we will consider expanding over time and are looking to talk to other qualified systems integrators as well. So basically through an existing channel that is being looked at in terms of expansion.
So David, another question, is there a certified dealer program?
There will be in terms of the physical aspects required in the field should you ever have to service as the integrator. However, Sony technicians, Sony engineers do perform the installation work that is on site. Any other cable pulling for audio, for example, if you're putting background music in, that kind of thing, we take care of all of that as well. So essentially, it's an installed product when you purchase it from your dealer. Great. Well, I think we're just about at the top of our hour or getting very close. We wanted to thank everyone, of course, for taking the time today out of your schedule. Do get in touch with your local Sony representative. Do find more information on LinkedIn. We have direct links, of course, to the folks that you need to get with in your area, and we can send you all the information directly just by making an inquiry on LinkedIn. We greatly appreciate everyone's time today. We appreciate you taking the time out of everything else that's going on. Above all, stay safe, stay healthy, and we hope to see you all again soon. Take care.